So here we have this radical expression and we have to simplify. Okay, so we have three radical expression, square root of 216, negative 4, square root of 24, and square root of 3. So we have these three radical expression. Okay, for all of these three radical expression, what is the common thing? What is one common thing that we see for all of these three radical expression? Yes, index is 2, right? So for each radical expression, we have 2 as an index. And whenever we are adding or subtracting radical expression, we need to have an index same. And what is the next thing we need to have same? We need to have the radicand. So radicand is the expression under the radical sign. Okay, so if we take this first radical expression, 216 is the radicand. For the second, 24 is the radicand. For the third, 3 is the radicand. Whenever adding or subtracting, make sure to check index and radicand. They have to be exactly same. But if you are multiplying or dividing the radical expression, if we need to have only index same. Okay, now we have a 216. Now let's rewrite 216 as a product of prime factor. So for that, we divide 216 by the smallest prime number, which is 2, right? 2 divided by 216 is 108. The smallest prime number that divide 108 is 2. So 2 divide 108 is 54. Okay, now the next smallest prime number that divide 54 is again 2. 2 times 27. The smallest prime number that divide 27 is 3. 3 divided by 27 is 9. And 9 is 3 times 3. So we can rewrite 216 as, so 216 is 2 times 2, 2 times 2, times 2, times 3, times 3, times 3. Okay, so let's replace our 216 by this prime factor. So we have 2 times 2 times 2 times 3 times 3 times 3. Negative 4, and we have 24. Let's do the same thing. So how can we rewrite 24 using a prime number? So it is 2 times that's 4. We need to get 8 times 3. Is that 24? That's 24, right? Plus square root of 3. Any question up to here? We rewrite our each radicand as a factor of prime number. Okay, now our index is 2. We have a square root. Index is 2. So we make a pair. So we make the same fact. So we make a pair of these two. Okay, we make a pair of this number. We make a pair of this number and write in an exponent form. And our exponent has to be 2. So this is square root. So 2 times 2 is same as 2 is square. And we have this 2 remaining. 3 times 3 is 3 square. And we have this 3 left. Negative 4 square root. 2 times 2, that is 2 square. We have 2 as it is, 3 as it is, plus square root of 3. If your index is 3, you make you write 3 factor together. Okay, you write 2 cube, but our case index is 2. Now our radicand, so they are in a product form. Okay, in between each of these radicand we have a product. So the radicand with the exponent 2 can be written outside the radical sign. So we have this radicand with the exponent 2. We have this radicand with exponent 2. We can write this number outside the radical sign. And when you write, you do not write down the exponent. So we have 2 from here and we have 3 from here, times 3 square root. Now what is left under the radical sign? We have this 2 times 3 is under the radical sign, negative 4. In the similar way, this radicand has an exponent 2, which is same as the index, so 2 comes out, so it has to be product sign, square root, and we are left with 2 times 3 plus square root of 3. Now let's simplify. 2 times 3 is 6, square root 2 times 3 is 6, minus 4 times 2 is 8, square root 2 times 3 is 6, positive 3. Now, do you see any like terms or like radicands? The very first two radical expression. So these two radical expression, they have exactly same index, which is 2, and they have exactly same radicand, which is 6. So we can simplify these two radical expressions. So 6 minus 8, which is negative 2, and do not forget square root of 6 plus square root of 3. And this is our final answer, okay? Square root of 3 and negative 2 square root of 6. These are not like, so we can't add unless you use the calculator, okay? But you are not required to use calculator here. So this is our final answer. Okay, any question up to here? Okay, now we did, so okay, so let me go back to one more example here where we have to rationalize the denominator. So let me take that example, okay? Square root of 18 over 15. So here we have square root of 18 over 15, okay? Now we can rewrite this square root of 18 over 5 as a square root of 18 divided by square root of 5, okay? And this is from our property. So we had a property, so here quotient rule, okay? And according to quotient rule, so if we are dividing, okay, let's say we are dividing a and our index is n by the nth root of b. So we are dividing this radical expression by this radical expression, okay? In order to divide, we must have a same index, and both of these radical expression have exactly same index n. If this is the case, then this will be nth root of a divided by b. Now in our case, we are given this right side, okay? So if you compare with this one, and we are, since these two are equal, so we are separating here, okay? So using this property, square root of 18 over 5 is same as square root of 18 divided by square root of 5. Now in our denominator, what kind of number do we have? What kind of number is the square root of 5? Is this rational number or irrational number? It is a irrational number, okay? And our target is making denominator rational, okay? That is rationalization, okay? So that's what we are asked to do here. So we have to rationalize denominator, means we have to have a rational number in the denominator. We are given with square root of 5, which is irrational number. Now we have to get rid of square root of 5, and we need to have a some rational number, okay? Now before this, so if we multiply square root of 2, which is a irrational number, by the same irrational number, what do we get? So what is the square root of 2 times square root of 2? This is square root of 2 times 2, which is 4. And square root of 4 is 2, right? And what kind of number is this 2? Rational. So if you have a irrational number, and if you multiply that irrational number by the same irrational number, we will end up getting a rational number. Similarly, for example, let's say we have a square root of, okay, let's say we have a cube, okay, so this has to be for the square root. So let's say we have a square root of 3, and you multiply square root of 3 by square root of 3, we get 3 times 3, which is 9. Square root of 9 is 3. So here we have a irrational number. We multiplied this irrational number by exactly same irrational number, and we end up getting a rational number. Now, in our case, our irrational number is root 5. Now, how do we get rid of this root 5 from the denominator? What number do we have to pick to multiply so that we can get rid of square root of 5 from the denominator? Is it 5? It has to be square root of 5. Okay, so you multiply by the same number, same denominator. And when you multiply a fraction, we have to multiply numerator as well as denominator. So let's multiply in our numerator as well as denominator by square root of 5. So in the numerator we have square root of 18 times square root of 5 divided by, in the denominator we have square root of 5 times square root of 5. So here we are multiplying two radical expression, okay, and same thing for the denominator. To multiply we need to have a same index. So this is also square root, this is also square root. Now how we multiply this? You write down this square root and multiply the radicand. 18 times 5 divided by, same thing in the denominator. Write down the square root, multiply radicand. 5 times 5. So this is 18 times 5, 90 divided by square root of 25. Now, so let's try to simplify. So we have square root of 90. Okay, how can we rewrite 90 as a product of prime number? So 2 divided 90 is 45. 3 divided 15. Then 3 times 5. So our 90 is 2 times 3 times 3 times 5 divided by square root of 25 is 5, right? This is, now our index is 2 and we have 3 times 3. So we have 2 3 prime number. So we can rewrite this as a 2 times 3 square times 5 divided by 5. Now from these 3 radicand, which radicand come outside? 3, right? It has exponent 2, which is same as the index. So you write down 3 outside the radical sign, and the remaining 2 times 5, 10 stays under the radical sign. And this is our final answer. Okay, so we had square root of 5 as our denominator, which is the irrational number. Now we ended up with 5 as a denominator, which is a rational number, and this is a rationalizing. Okay, so rationalization means you are making your denominator as a rational number. Okay, your denominator has to be rational number. It's okay if you have a irrational number in the denominator, sorry, in the numerator. So this number is irrational number. Okay, but our denominator 5, which is a rational. Okay, so you are always making your denominator as a rational number whenever you are rationalizing. Okay, okay, so whenever you do a rationalize, make sure you multiply by the same number. Okay, if you have a one radical expression. Okay, now so let me combine these two topic and combine these. So for example, so let's say we have a number with a rational number as an exponent. So we have m over n as an exponent. And what kind of number is m over n? It is a fraction, and fraction is a rational number, right? So if we have power, okay, so this is the power or this is the exponent, and if your exponent is a fraction, we can rewrite this number in a radical form. Okay, we can rewrite this with a radical sign. To write down this, so you write down the radical sign. So we are given with a number and exponent is a rational number. If this is the case, we can rewrite this number as a radical expression. For that, write down the radical sign. Okay, now this denominator, which is n, denominator of exponent, that is the index, so your n is here. Okay, and this m will be the exponent for this base a, so a to the power m. These two expressions are exactly same. Okay, now let's take an example. So here we have 27 to the power 1/3. So let me copy that question. So we have 27 and we have 1/3. So this is the exponent. This exponent is a fraction. Okay, now let's rewrite this expression, this number, using a radical sign. So you write down your radical sign. Okay, the denominator, which is 3, the denominator of this fraction will be the index. You write down 3 here. Okay, the denominator will be the index. Then you write down 27 and numerator will be the exponent of 27. Now let's simplify this. So this is, cube root of 27 to the power 1 is 27, right? Now how can we rewrite 27 as a product of prime number? 27 is, or we know the cube of 3 is 27, right? Yeah. So the cube root of 27 is 3, so we know that. Or if you want to add more steps here, so that is 3 times 3, this is cube root of 3 cube. Now we have the index 3, we have the exponent 3, so the radical sign go away and we are left with 3, and this is our final answer. Okay, any question here? Now let's simplify part B. So in number B we have negative 36 and the exponent is 1/2. So let's write down this using a radical sign. So at first you draw a radical sign. What will be the index for this case? Index is every time the denominator of exponent. Okay, so 2 is the index. Now are we required to write down 2 here? No, right? We understand if we do not write index, it's always the square root, right? So this is square root of negative 36 to the power 1. So this is square root of, so negative 36. We have negative 36. Now, do we have a real number here? Okay. Let's double check this one. So we have negative 36. Okay, now here, now is this 1/2? So I have a question here. Now is this 1/2 the exponent for negative? That 1/2 is only for 36, right? Not for negative. So negative is outside the radical sign. Okay, now here this negative will be outside because 1/2 is not for negative. Okay, now this is square root of 36 is 6, so this is our final answer. And if we have a radical expression, we can always get rid of radical expression. Okay, for example, let's say we have a 5th root of 2 cube. So we have a radical expression here, and we can rewrite this number without radical sign. And for that, your index 5 will be the denominator. Okay, so this index 5 will be the denominator for this exponent. So this is 2 to the power 3/5. So you can go from left to right or right to left. Okay, so you can get rid of radical sign, as well as you can just write your rational exponent using a radical sign. Okay, and we do have more example here. Any question up to here? Okay, so here, okay, so we have more examples. It's asking us to simplify these positive exponents. So we have 25. So we have 25 to the, and the power is 3 over 2. Okay, you can, okay, there are like different ways of solving this one. Okay, if you want to use a radical sign, you can still use it. Okay, how can we rewrite this number using a radical sign? So at first, what do? We draw a radical sign, right? What will be the index of this radical sign? The index is always denominator of, so 2 is the index. So if we have a 2 here, it is a square root, right? So no need to write 2. And what do we have under the radical sign? 25 cube. Okay. So this is, now for 25 cube, can we rewrite 25 cube as a 25 square time 25? Do you all agree? So, okay, so for example, we have a cube. A cube is a time a, right? And we can rewrite this as a time a, as a square time this a. So a cube is same as a square time a. Do you all agree? Okay. Now the reason we are writing 25 cube as a 25 square is because our index is 2. And if our radicand has an exponent 2, we can write this number outside the radical sign, right? Now here we write down 25 outside the radical sign. Under the radical sign, we are left with this 25. So 25, what is the square root of 25? 5. 25 times 5 is it 125? So 125 is the final answer. So this is one way. Yeah. So if you, yeah, here we didn't even use a calculator here. Okay, any question up to here? Okay, now let's go to number B. So number B, we have 16 s to the power 4 over 3 t to the power minus 3 and whole power 3 over 2. Okay. So it tells us to have a positive exponent. So we only need a positive exponent. Okay, now how can we simplify this? Okay, so using the laws of exponents, that what we did in our last section, this exponent, this 3 over 2. So this exponent is for every term here, okay? So you distribute this 3 over 2 for each number. And we can do this because these numbers, 16 s to the power 4 over 3 and t to the power minus 3, all they are in a product form. So we can distribute, okay? So this is 16 to the power 3 over 2 times s 4 over 3 times 3 over 2 times t to the power minus 3 times 3 over 2. Okay, since we have a product here, this 3 over 2, you can distribute this 3 over 2 for each number, each expression, to 16 to s to the power 4 over 3 and t to the power minus 3. Okay, now what is 16? Can we rewrite 16 as a square of any number? 16 is a square of 4, right? So let's replace our 16 by 4 square. Okay, so 16 is 4 square, and do not forget this 3 over 2. We still have 3 over 2 time. Now in the exponent, how do we simplify this? So how do we simplify this? We are multiplying two fraction. How do we multiply two fraction? You multiply numerators together and denominators together, right? So we have s 4 times 3, 12 divided by 3 times 2, 6 time t, same thing, negative 3 times 3, negative 9 divided by 2. This is, so similarly 2 times 3, 6. So we have 4 to the power 6 divided by 2. S 12 divided by 6, that is 2. T negative 9 over 2. So we have 4 as it is. 6 divided by 2 is 3. And we have s square. And we have t to the power 9 over 2. Now what is 4 cube? 64. 4 cube is 64. We have s square as it is. And we have t to the power 9 over 2. We are asked to have a positive exponent. So which has a negative exponent here? T, right? T has a negative exponent, negative 9 over 2. Now how do we get rid of that negative exponent? To get rid of negative exponent, you switch from you just switch numerator and denominator, right? So here we have t to the power negative 9 over 2 in the numerator. Now if you take this expression to the denominator, negative, there is no more negative. Okay, so this is 64 s square divided by t to the power 9 over 2. That's how you get rid of negative. Okay, you switch numerator and denominator. Now let's do one more here. So we have this rational number as an exponent. Let's rewrite this using a radical sign. So we have 64 s square divided by, so you have a radical sign, the index is 2, it means we have a square root, no need to write 2 here, and we have t to the power 9. And yeah, you can just write this as your final answer. There is still a more to simplify, but if you have up to here, it should be okay. So our target is making a positive exponent. That's the instruction here. It tells us to positive exponent. So if you have up to here, still fine. Okay, we all have positive exponent. We have a 2, we have a 9 over 2, which is a positive exponent. So make sure to have a positive exponent. Okay, any question? So this is just a revision. Okay, we'll like when we start our chapters, we'll go over these topics again. Okay, all right, so we have number C. Okay, does anyone have any question for part B? Okay, now let's go to number C. So in number C we have x to the power negative 7 over 3, y to the power 5 over 2 divided by y to the power negative half x square, and in the numerator we have cube here. So as like number B, in between this term and this term we have a product sign here. Okay, and because of that we can distribute this exponent 3 for each of these expression. So this will be equals to x to the power negative 7 over 3 times this 3 time y to the power 5 over 2 times this exponent times 3. That's in the numerator. So in denominator, just let's copy our denominator, negative 1/2 times x square Now let's simplify our exponent. We have x to the power, so we have x to the power. How do we simplify this? So we have a negative 7 over 3 times 3. What is that equals to? So you are multiplying a fraction and a whole number. So we multiply the numerators. Okay, negative 7 times 3, that is negative 21 divided by 3, that is negative 7, right? Times y to the power 5 times 3, 15 divided by 2. That's our numerator. In the denominator, let me write down x square first. X square times y to the power negative half. So here we have more to simplify. Now we are dividing x to the power 7 by x square. Both of these has the same base. Okay, so we can divide, and when you divide the rest exponent expression, you subtract the exponent. So negative 7 minus this exponent times, same thing for the y to the power 15 over 2 minus the exponent of denominator, which is negative 1/2. So this is using our exponent rule. Now this is x to the power negative 7, negative 2, negative 9 times y to the power 15 over 2, negative times negative half, that is positive 1/2. So we have x to the power negative 9 times, now we have a fraction plus another fraction. And how do we add two fraction? And in order to add or subtract two fraction, what we need to have? We need to have a common denominator, right? And both of these fraction has exactly same denominator too. So in this case, we can simply add numerator. So this is y to the power 15 plus 1, 16 divided by 2. And this is x to the power negative 9, y to the power 16 by 2 is 8. Our target is writing exponent with a positive number. So this is negative. So let's take this expression to the denominator. So we have y to the power 8 divided by x to the power 9. And this is our final answer. Okay, do you have any question? Okay. Can I go to the next page?